Good morning, Year 11s. I want to go through a couple of these gas calculation questions with you, just in case you're having trouble, especially if you weren't here last week. So last week, we established that the things that affect the volume of a gas are the temperature of the gas and the pressure, but not what gas it is. So we invented this ideal gas concept that is kind of theoretical, but it gives us the freedom to do these types of calculations. And it tells us that 1 mole of any gas at standard temperature and pressure, which is 0 degrees Celsius and 100 kilopascals, at standard temperature and pressure, 1 mole of gas has a volume of 22.71 litres. So as long as we're working at standard temperature and pressure, if you know the volume of a gas, you can work out the number of moles. You know the number of moles, you can work out the volume. The formula is in your data sheet. There it is. There you go. Number of moles of a gas is the volume of the gas divided by 22.71. So if you know the volume, if you know the number of moles times 22.71 will give you the volume. And down here, standard temperature and pressure, it tells you that it's 0 degrees Celsius and 100 kilopascals. So back to the equations. There it is. All right. So there's a couple of things we've got here. First, the first question, and you know that if you can, as soon as you convert something to moles, you can compare the amount of reactants with the amount of product. So for any of these questions, you always have to figure out how many moles there are, and then you can use that ratio, and then in the end you can convert back to mass or to volume or whatever. So the first question, and it's on page 323, says how many moles of carbon dioxide are generated when 5.5 moles of propane are burnt completely in oxygen? So you have to write the equation, and you have to know that propane burns in oxygen to give carbon dioxide and water and also heat energy. So propane, C3, methyl ethyl propyl, C3. I always get those first two mixed up. So it's going to have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, C3H8. If you're not sure, draw it. Plus O2 gives CO2 plus H2O. All right, and then we balance it. I always start with the number of carbons. I don't know if that's the best way to go. C3 on the left, so I need 3 of those over here. We got H8 on the left, so I need 4 H2s there, and then we got to work out how many. This one always has to be even. If you've got an odd number, you're going to have to double it. This time it's even, so it works. 3 O2s, and then another 4. That's 10 O's. That's 5 O2s, which goes here. Now that you've got a balanced equation, let's read the question again. How many moles of carbon dioxide are generated when 5.5 moles of propane are burned? So, you know, we know that that's 1 there, but we don't write it. So this is going to be now 5.5 moles of C3H8. Let's write that, C3H8 will give us, so the way they do it in the book is this 3/1, right? 3 of those, 1 of those, 3/1 times 5.5 moles of CO2, which is, what's 3, 5.5 is 15, 16.5 moles of CO2. All right, so go back to the question again. 5.5 moles of propane. How many moles of carbon dioxide? Oh, we've got that. There's our answer there. Done. All right, I may have to rub this out to do another question. Give me a sec. Okay, this one they've given you a balanced equation, and it says if 50 mils of methane is burnt, what volume of oxygen will you need? Calculate the volume of oxygen required for complete combustion under constant temperature and pressure conditions. So at a given temperature and pressure, you know, we can work out how many moles of methane there are. Number of moles of methane is going to be equal to the volume divided by molar volume. So it equals 50 mils divided by 22.71 litres. Okay, we're going to have to change units. 0.05 litres out of 22.71 litres. And then we can work out the number of moles of methane, and we can double it to get the number of moles of oxygen. And when we convert that, because the number of moles is equivalent to the volume, 50 mils of methane is going to give you double that volume of, you're going to require double that volume of oxygen, right? Because each one has the same volume for a mole. Each one has the same. So 50 mils, you're going to end up with 100 mils. So I don't think I'm explaining that very well, but 50 mils of CH4, because the moles is directly related to its volume, is going to give you 2 lots of 50 mils of O2. Right, so you're going to end up with needing 100 mils of O2. And that saves you going through those lengthy calculations. But you could work out the number of moles of CH4, double it to work out the number of moles of oxygen, and then work back to volume by multiplying the number of moles by 22.71, and you're going to end up with 100 mils. So sometimes they're easier than they look. Now I'm just flicking over to the review questions, and I want to have a look at question 18. It's on page 329. It's a bit more complicated, but it steps you through in a way that your exam won't. But let's have a look at that one anyway, and I'll just write it on here. Okay, so you're given a balanced equation. That's a good start. It says, suppose that 350 kilograms of iron oxide reacts with excess carbon monoxide, according to this equation. And the bottom part says, determine the volume of carbon dioxide measured at STP. So without being given those extra steps, because you won't be in the exam, you're given a mass of iron oxide and you're asked for a volume of carbon dioxide. So you're going to need to convert from mass to moles, use the ratio to find the number of moles of carbon dioxide, and from there you can work out its volume. So first thing, we should write down the things that we do know. Mass of iron oxide is 350 kilograms. And remember, we've got to convert that to grams to work with it. Reacts with excess carbon monoxide, and we're trying to find out the number of moles. So we need to know the number of moles of iron oxide. Number of moles of iron oxide is mass over molar mass. Kilogram is 1,000 grams. So let's just put this in straight into grams. Over the molar mass, let's work out the molar mass of iron oxide. $159.7 grams over 159.7. Okay, so now we can work out the number of moles. I've got my calculator. Divided by 159.7 is 2191.61. That'll do for now. So is 2191.61. Of iron oxide. For every 1 mole of iron oxide, I've got 3 moles of carbon dioxide. So leaving that number in the calculator, I'm going to triple it. But first I'm going to write down what I'm doing. Number of moles of carbon dioxide is 3 times the number of moles of Fe2O3. I don't need to write down that number times 3. I can just write down the answer. Times 3, 6574.83. 6574.83 moles. Now that I know how many moles, I can work out the volume of carbon dioxide, but I'm going to go back and reread the question. So determine the number of moles of iron oxide, which I've done. This is the steps. Determine the mole ratio of carbon dioxide to iron oxide and use it to calculate the number of moles of carbon dioxide produced, which we've done. Determine the volume of carbon dioxide. So the volume, and you can go to your, let's do that. Go to your data sheet. Where did I put that? There it is, data sheet. We're going to go number of moles is volume divided by 22.71. So the volume is the number of moles times 22.71. Volume equals 6574. I haven't cleared the calculator either because I want to keep that number in there. Volume of CO2 is 6574.83 times 22.71. So I'll just pick up the calculator and go times 22.71 equals, and I got 149313 litres. 149313 litres. Well, we should probably turn that into kilolitres. 149.3 kilolitres. Now, so for our then looking at significant figures, the question has 2 significant figures. So the answer has 2 significant figures. So we're going to change that. Instead of 149.3, we're going to make that 150 kilolitres. And I might even write there of carbon dioxide. So these are very similar to the ones you've done before, where you convert a mass to a number of moles. You use the molar ratio to work out the mass of the product, or the mass of reactant, whatever you asked for. This time we're using volume. We might be using mass as well. They'll probably tie that in there somewhere. If you can convert it to moles and use the ratios to work out the number of moles of the whatever it is you're looking for, and then you can convert it back to mass, back to volume, then you can work through these questions. And the most important thing is that you're writing down all the way through, what is it that you're giving me the number of moles of? What is it that you're giving me the mass of? Make sure you put that in there so that you can get all the marks you need. Have a go through those questions. Ask me if you get stuck and I'll try to answer you straight away. Okay. Have fun.